Hi, I am Monis. I would like to demonstrate a simple project using Tinkercad, which is an online simulation platform for electronics and 3D design. First of all, let us discuss what is meant by Tinkercad. Tinkercad is a free online tool. It is used for circuit simulation, Arduino coding, and for 3D design. No hardware components needed. Tinkercad allows us to design and simulate circuits without any physical components, which is very useful for prototyping. So, this is an example for 3D design, and this is an example for circuit simulation. Next, let us see how to open a Tinkercad. So first of all, you want to go to Google and type Tinkercad. After typing Tinkercad, you will appear this like Tinkercad, and after opening, you want to sign up with your email or your Google account. After signing, you will appear this like. So in this 3D design circuits, code blocks, these are the things available after opening Tinkercad. And after opening this, you will see this workspace. In this only you are going to do a project using and circuits. So this is the exact simulation after completing this project in Tinkercad. So next, let us see practically how to open a Tinkercad and how to do a project in that. So next I am going to open Tinkercad. For that I am going to Google and type Tinkercad. So this is the Tinkercad first website link. Open this. You want to log in with your personal accounts. If you have an already have an account means sign in with Google. So I am going to log in with my email account. So after logging with my email account, you will see this like. So this is for 3D designs. You will if you want to create a 3D design means you want to create in this, and this is for circuits, and this is for code blocks. So now we are going to create a circuit simulation. For that, you want to click this create symbol and open circuit. So these are the circuits workspace toolbar. This is an circuits workspace toolbar. These are the toolbar icons. This is copy, paste, and delete, undo, reverse last action. Next redo. It will reapply the undo action. If you want any notes or comments, you can use this comments box, and inspector, view or edit properties. Next, this is for start simulation. See how it behaves. Code button. This is code button. Okay. Open Arduino code editor, block on it. Next, this is our the basic components we are using. Resistor, capacitor, polarized capacitor, diode, xenon diode, inductor. So in this most of the elements and the components are we are used in a daily life. So first we are going to create an project, ultrasonic door alert system. What is the main purpose of using this Tinkercad? Means the main purpose of Tinkercad is to help beginners understand electronics and design without needing any physical components. Okay, so what are the components available in this Tinkercad? Means uh, Arduino. Arduino is a microcontroller. It is used to control everything. Next, next, next breadboard. Breadboard helps us to connect without any soldering, and LED. So LED output device for light indication. Register limits current to protect LED sensors. Next we are using sensor temperature, and for ultrasonic used to detect environment changes. So things are the what are the things available in Tinkercad means 3D design workspace, circuit simulation workspace, and code editor. So now I will demonstrate a ultrasonic door alert system using this Tinkercad. So first of all, let us take Arduino. So Arduino, it is used for control everything. Next we are going to take piezo. Next we are going to take ultrasonic sensor. It will sense the distance of. So now I am going to connect the components. So this is used for choosing the colors, what colors we want to do. So negative piezo I am going to connect in ground, and positive I am going to connect in minus 10. So next I am going to connect ground, ultrasonic ground to ground. So next I am choosing red color. So next I am choosing green color. So from echo I am going to connect to Arduino 3. So next I'm going to connect. So next I'm going to connect. So next I'm going to connect VCC power to 5 volt. So now I will start the simulation, means it will run. So this is we can see blocks plus blocks text, or with text alone. So this is an code. We can see what are the things here available. So let us type. So int trigger pin is equal to 2. So this will send an ultrasonic signal to the microcontroller. Next we are going to use int echo pin. Okay, echo. Next we are going to use echo pin is equal to 3. It will receive the signal. Okay, next int buzzer design, int buzzer pin. Okay, next we are going to use buzzer pin. So these are the this first 3 line is known as pin definitions. Next we are going to use variables. Next we are going to declare an variables long time. Next int distance. Next we are going to use void setup. So why this is this void setup using in this program means it will runs only once when Arduino will start. Okay, next we are going to use a serial begin. So next we are going to use pin mode trigger pin comma output. Okay, next we are using echo pin. Okay, next we are going to use echo pin. Next we are first input, next out next first output, next input. So first output it will trigger pin sends signals. Next echo pin receives signals from the input. Next pin mode buzzer. Next we are going to use a buzzer pin comma input, sorry, output. Buzzer pin gives output like on or off. Next we are closing the loops. It is the end of the setup. Next we are next again we are going to using a white loop runs again and again continuously until the program will execute. Next we are using a digital write. trigger pin comma low. So it will first make a trigger low. It will send an ultrasonic signal. Next, digital write digital write sorry uh, wait for a few minutes. Digital microseconds. We are declaring a 10. Okay. Next, digital micro. Next, we are again using digital write trigger pin comma low. Next, we are using a distance formula. Time start 0.034 divided by 2. So it will multiply by speed of sound divided by 2. This is a distance formula. Next we are going to print the distance. Serial dot print is equal to distance next we are using that print. Sorry guys, wait for a few minutes. Serial dot print again. Next we are going to print a distance. Next we are using if condition. If distance lesser than is equal to 10, if object is within 10 centimeter. Okay, what if object is within 10 centimeter? Buzzer pin comma high serial dot print ln door open. Okay, close the bracket. Next we are closing the condition. Next we are using else. Next we are using delay. So now I will start the simulation. So let us check what is happening here. So the condition of this project is distance lesser than 10 centimeter is equal to buzzer means it will on. Distance greater than 10 centimeter means buzzer off. It will measure how long whose pin stays high. Output object near means door open, buzzer on. No object means door will close and buzzer will off. Ultrasonic sensor measure distance if object is near. If object is near means it will the buzzer will on. Uh, if buzzer is far means buzzer off. So this is the main concept of this project. Okay, thank you guys. So here is the output. Door is equal to closed, distance is equal to 1 on 2. So the main condition of this project is distance lesser than 10 centimeter means buzzer will on. Distance greater than 10 centimeter means the buzzer off. It will measure how long which pin is stays. Output object near door will open, buzzer will on. No object means door closed, thus buzzer will off. So ultrasonic sensor measure if the object is near means the buzzer will on. If the far is off means distance.
Don't forget to subscribe to Tinkercad Ulagam for exciting electronics, Arduino, robotics, and STEM projects. Let's build the future together.